Okay, let's go through the solutions of these questions from the book that you were practicing with from Tuesday. So in this diagram, one figure is an enlargement of the other. Use the grid and a straight edge. Straight edge just means a ruler, because there's different types of rulers, to write down the coordinates of the center of enlargement. So what do they actually want us to do? They want us to construct the center of enlargement. So we're going to join vertices together as best as we can. And looks about right. And once we've done 2, we'll have our answer. And look, there it is. It's 2 on the y-axis is what it's looking like. Right, let's just confirm it with another one. These 2 vertices together. Yeah, they're all going through the same point. So even if you didn't draw the lines, if you went around with your ruler, you'd quickly find that center of enlargement there. It's at the same point, regardless of which vertices we pick. So the center of enlargement there is the point 0, 2. 0, 2. 2 in the y direction, nothing in the x direction. If b is an enlargement of a, write down the scale factor. So this one, a, let's just pick this side, is 2 boxes up, and this is 4 boxes up. So my scale factor will be 4 divided by 2, which is 2. My scale factor is 2. Here's a question though. What about if it was a contraction rather than an enlargement? What if A was the one that we'd enlarged from B? What would the scale factor be then? Well, it would just be the opposite way around. 2 over 4, which would be a half. So when the scale factor is less than 1, we're not enlarging something, we're shrinking it. Finally, if A is 15 square units, find the area of B. So we're going to multiply by k squared. So the area of B will be 15 multiplied by k squared, 2 squared, which is 60, I believe, but let's just check. So 2 squared is 4, and that is 60 square units. 60 units squared. Okay, so hopefully that was straightforward enough. This bit might have caught people out. Let me know if there's any part of that you don't understand, please. Now, in the next question here, in question 12, A, B prime, C prime is an enlargement of the triangle ABC. And of course, this must be my center of enlargement. And they said that AC is 8, it's marked in there. C to C prime is 12. So we know that the full distance from A to C prime must be 20. B, C prime is 25, and we've got some work to do then. So first of all, the scale factor of the enlargement, let's use this for question 12, my scale factor, and it might help to draw them side by side. A, B, C, there's 8, and A, B prime, C prime. So that's 25 and that's 20. So I can work out my scale factor from these. So K will be 20 divided by 8. Go ahead and do that calculation. 5 over 2 or 2.5. So K is 2.5. You can leave it as a fraction as well, that's fine. Then the next part, find BC, find this. Well, it's going to be the longer side here, 25 divided by that scale factor, divided by 2.5. So that should be 10, but let's do it in the calculator. 25 divided by 2.5, which is 10. 10. And then fill it in straight away. So that is 10. And then the next part, find the ratio of AB to AB prime. And we don't have numbers for these. So we can't fill in numbers, which means we just have to recognize the fact that this will be the same as the ratio of any of the other two pairs of sides together, of AC to AC prime. So that is going to be 8 is to 20, which simplifies to 2 is to 5. The important thing is that you have this in the right direction. I saw somebody did hand up their work to me and they were doing this correctly, but they were mixing up the numbers. So you've got to follow the pattern that's given. They started with the smaller triangle here and the larger triangle here. So my ratio must be small is to big as well. It has to match. Okay, finally, we're told that the area of ABC is 16. So can I find the area of the bigger one? So the area, part 4, the area of AB prime, C prime, will be the area of the smaller one multiplied by K squared, 2.5 squared. So that's going to be 16 by 2.5 squared. And that is 100. And were they centimeters? No, square units. So that is 100 square units. Okay. Right, question 13 then. This diagram is reduced on a photograph. So a reduction is like an enlargement, but we're multiplying by a fraction scale factor. So my scale factor in question 13, turn this way, in question 13, my scale factor, they told us, is 2/3. If the height of the original diagram, my object, height is going to be 156, what will the height of the reduced diagram be? So the new height is just going to be h multiplied by my scale factor. Just like we've been doing before, when it's been a bigger number, it's exactly the same calculation. 156 multiplied by 2/3. So let's use the calculator for that. 156 by 2/3, and that is 104. And did they say centimeters? Millimeters. So that is going to be 104 millimeters. That's our answer. Okay, part 2. If the label is reduced to, so the new label is reduced to 28 millimeters, it's over here, what was the original label? Well, now I divide. So the label, the original label, is going to be 28 divided by my scale factor divided by 2/3, which is the same as multiplying by 3/2, but you know what? You can just use the calculator for that. So you can let the calculator do the heavy lifting of dividing by a fraction. And you get 42 millimeters. Because there's no marks going for showing that working out. If you ever want to do it without a calculator, you turn this upside down and multiply. So that would have been 28 multiplied by 3/2, which of course is 14 by 3, which is the same as 7 by 6, which is 42. That's where it came from. Okay, question 14 then. In the given figure, box B is an enlargement of box A. Write down the value of the scale factor of the enlargement. So for question 14, my scale factor, I go the bigger one. Doesn't matter which side I pick, so long as they are corresponding, matching each other. So K will be 6 divided by 2, which is 3. My scale factor is 3. Part 2, what is the relationship between K and the scale factor for volume? Now, we didn't talk about this, but what happens? The volume of A will be 5 by 2 by 2, which is 20 centimeters cubed. And the volume of B will be 6 by 6. Let's do it in the same order. 15 by 6 by 6. So 15 by 6 by 6 is 540. And what have I done there? To go from here to here, what did I multiply by? So 540 divided by 20 is 27. Now, would you notice, maybe you think about the fact that scale factor is squared for area and it is cubed for volume. So K cubed. So what they were looking for here, and this isn't necessarily a question that will come up, but it's good practice to think about this. K is cubed for volume. So the image volume divided by the object volume will always be the scale factor cubed. Okay, don't worry if you didn't really get what you were being asked to do in that question. That was just something to have you think about it and think about those relationships at the end. Okay, so we're going to go on from here. I'm going to get you to do some constructions today, and I'm also going to set some work on functions for you as well. Okay, thank you.